All right. How are we doing? We can adjust a little bit there. There we go. All right. Oh, I gotta take this one out because I don't use that microphone for the stream. All right, how's it going? Welcome back to the stream. Welcome to another week. I am Agent Ultra. I'm going to be hacking for you today. I'm working on a little project to add or create a database client for a database called TigerBeetle. What is TigerBeetle? TigerBeetle is a financial transactions database. It's a very specialized database for doing online transaction processing, and it's written in Zig. It's a pretty neat little project, and I'm learning more about it by writing a client for it in Haskell because they don't have a Haskell client for it yet. And I program a lot of stuff in Haskell, so what a way to learn. And that's what we're going to be working on this week. So this is what we've been working on for a little while now. And at this stage, we've got like a synchronous version of the client working now. We can create accounts, and tonight I'm going to be basically working on adding more commands to the synchronous client. And then on the road to 1.0, I think we're going to need an asynchronous client at some point, and some documentation and all that kind of open source goodness. So without further ado, let's just jump into it and get going, shall we? By the way, if this is your first time tuning in, welcome. Thanks for watching. Thanks for hanging out with me. I'm perfectly fine with backseat programming, taking pauses to chat and like answer questions or whatever. I know not everybody programs in Haskell, so if you're curious about what's going on, feel free to ask. It's all good. So in the meantime, we've got quite a bit of work to do still. We got sync here. This is where the synchronous library is kind of defined for now. We have create accounts. Might want to break this up into separate modules at some point in time, but now we can create accounts. What else can we do with accounts? Well, let's look at the client, the C client library, or the header for it at least. Create accounts. We can... There's a create accounts operations. Create accounts, create transfers. Hey, Twitch TD, welcome back to the stream. Thanks for coming back and saying hello. What's up? How's it going? We can look up accounts. We can get account transfers. We can get account balances. Query accounts, query transfers, and get events, it looks like. So let's do lookup accounts, I guess. Figure out how that one works. Adpex twin. Dun-dun-dong. What's going on? Okay, so we create accounts. I just want to make sure that actually we're done with this one. List of accounts. Create the request packet pointer from the create account params. We pack it in there. Then we submit the client. Awaiting the result. And the thing I wanted to make sure of. When we get the response, what do we write in the response? TB response. Okay, and TB response is the list of things. Okay, just wanted to make sure that, because I remember when I first started on the create accounts thing, I did it one at a time, but I think we do we batch the accounts now, which is good. And then we pull out the array of results from that batch in the response packet. Okay. Cool. So moving on, let's do lookup accounts. Probably going to have an IO action for that. And think that's probably going to end up taking an account ID. Probably. Do I have a type for those? Really just ints. I mean, that's all they are kind of under the hood, I believe. Oh, right, the seg fault. Yeah, we did fix that. I think it was, if I recall correctly, a address bounds. And we were accessing an address out of bounds. Because we weren't doing the response packet parsing quite right. Yeah, the offset wasn't right. But I believe that's fixed now, yeah. Why don't we just do a quick little test run to demonstrate that? We'll get the server running. TB run. Tail the logs. And over here. Oh, well, in main, at least, I believe. Gotta change that because unless I create a new database. We're gonna create account 1111. You know what? Could probably. Yeah, we'll just do it like this. We'll just do 8, 1, something like that. Should be fine. And run it. Now when we actually got the proper create account part, we would crash here and get a seg fault, but this should just work. And there we go. Because the resulting list of things is empty. There's nothing there. So handle it properly now. Cool. And that actually gets created. So if we go into the REPL, tv REPL.sh here, we look up accounts, equals 8. All right, there's our 881 on ledger 8 with code 1. Boom. Pretty sick. Right. Sure. I'll just get rid of that. Yeah. Okay, so we gotta look up accounts, and I think that's going to be ints for now. I probably prefer to have like an account ID type in the API, just for reasons. But we'll do it this way for now, just to get it working. And we'll clean that up in a refactor pass, I guess. So we'll take the list of accounts to look up. I think you can do more than one. Yeah, because on the here you can do 1 or 2. Cool, so that'll be a sync client action. TV response. And I gotta be able to type. Okay, IDs. Something in there is what we gotta put. Oh, no, look up our accounts. There we go. Okay. That's what we gotta put in there. Okay, so just like this other function, okay, we got to get the sync state in order to get our client pointer and all that stuff. We're going to have to create a request packet, just like we did with create accounts. Probably going to look very similar to this, except it's going to be lookup accounts. We'll pass in those IDs. Check the status of the packet. This is almost exactly the same. Yep. Okay, and then we await the result, basically. Or we get the status, yeah. We check the status first, and then we await the result. In fact, this is all the same, too. Let's just pop that over there. Okay, of course, this isn't going to compile yet, so let's get GHCID going. Get our builder rocking. We'll fix those type errors. By first fixing my typos. Of which we already are off to a great start. So many typos. So little time. Okay, and now we've got to implement account.lookupAccounts. So this is going to create our little packet. Yeah, monad.io. I need a little consistency here. Okay, list of IDs. It's going to be int for now. And then we return a packet. Yeah, just like that. Okay. Okay, so how do we pack the package? In the accounts case, we create those TB accounts. That creates a raw TB account with C structs. Then create accounts packet. So we go down a layer to create accounts packet. Okay, with those TB account structs, I guess. And create a new foreign pointer to that packet. Okay. So we'll probably end up doing basically extremely similar stuff. Although I don't know if we're going to need to like do structs for the account IDs that we want to look up. Let's underscore that there. Let's look at the header library. Client T, query filter, account balance, accounts results, transfer account. Yeah, I guess we just pack the IDs and there's an array of ints in the data of the packet. maybe. Yes. Okay. Well, let's give that a shot. See how that goes. So we'll pack those IDs into an array. We'll have some kind of action, I guess, for something like that. And then we lift IO. B. Create the lookup counts packet. The TB count IDs, and then create a new foreign pointer. Do the TB packet pointer, and return that. Capital D, lowercase, oh gosh, lowercase d, bang. And not a struct. It's going to be a pointer to hints. Basically the ravens. I think that's probably right. Twitch TD says, by the way, I went to the URL on the top right of your stream, and it's throwing sync can't be reached. Yeah, I should probably... We're gonna fix that. I did report it to the group of the people running the site. They're on it. It's gonna take a bit though. There might be a new URL. I should probably pop that off though. Yeah. Unfortunately. I don't want to make stream that big. Eh. Yeah, well, we'll leave it. Anyway. Yeah, so I gotta fix that URL at some point. It's gonna get fixed. It'll come back. But thanks for checking it out. At least trying to. I'll definitely let folks know when it's back. Okay, so to pack those, we need to create an array. And that comes from pointer. Da, 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 da. Oh, we don't need in pointer. No, we need, what do we need? Alloc. There we go. We could probably alloc with that directly. I wonder if the data.array has anything for us. No. All right, those are different data structure. Okay. Cool, see alloc. Right, storable. Okay, and then we'll poke off set from there. So we give it a size argument, so that'll be the length of IDs in bytes times size of int. Should check the size on how you count ID size. I think it's 32. Oh, sorry, it's Word 128. So that means we could use, I think we can use wide word. embarrassing. Let's go. Come on. Wide word. There we go. Sorry, it should be 128. And that needs to be over here. Right, we don't have that function installed yet. Look up counts packet, a list of word 128. To IO, Maynard packet, TV packet. I'll just leave that undefined for now. Oh, that's the other module. Yeah. And foreign.storable. And foreign. .marshall.alloc. With one L. Not the Mathers. TwitchD feels like an open API standard to describe CFFI interfaces is missing. I feel like a lot of this can be done via genning Haskell or writing generic Haskell once given a spec. What do I think? Well, there are kind of things for that. See, foreign function interfaces are kind of complicated. Not really, but kind of. Haskell actually has a pretty nice one. And it has options for like a couple of different ways to do code gen for FFI, if that's what you're asking about. We do use one of them on this project. If we go to raw here, like, no, sorry, actually I got one of them pulled up like this. It's very minimalist in terms of the code gen. So like you still have to write out your type class, your storable type classes and stuff. Right. There are higher level ones that will generate even the storable instances for you. And the first attempt I did at this client library, that's what I tried using. But the way that, at least at the time, it's probably changed now, but at the time when I first attempted this, the header here was just a little bit too idiosyncratic for it and used some non-standard types, extensions provided by GCC, like this uint128t type def, that the generator couldn't do anything with, because Haskell's FFI only works with the standard C types, as like the ISO standard C types. uint128s are an extension type. They're not defined by the standard. So the Haskell FFI doesn't understand them. And it can't marshal primitive values between those. Yeah. And so I think under the hood, though, it's probably using, I think GHC is probably linking libffi and using that stuff to do a whole bunch of other code mess that needs to be done in order to actually successfully call another C program. But yeah, Haskell actually kind of natively understands the System 5 calling conventions. And there's like two different calling conventions available in Haskell too. The newer one is actually pretty nice. It lets you you can depend on values generated by macros, which can be very, very handy for a lot of different C APIs, whereas the original one couldn't. And so you had to like write out your enums in both Haskell and C and make sure you had the same macros and stuff, which was a pain in the butt. But no longer. So originally I was actually writing out the FFI by hand, which I think for a small project is actually not that bad of an idea to do. This isn't a huge library, right? It's pretty small. Like this tbclient.h file is pretty small. It's only like not even 500 lines of code, right? So like hand rolling this wouldn't be that big of an issue. Even hand rolling your FFI code for like a much larger library, if you're only going to use a subset of it, it's probably fine. You don't need to code gen the whole thing, right? Because the trade-off with code genning your FFI layer is that like it's going to generate a bunch of code, and you're not going to know how. You might not know how most of it works, or like if there's problems with it, you're going to be looking through, you know, hundreds of lines or a few hundred lines or 1,000 lines of code trying to figure out where it's generating the problem. And like that could be its own can of worms, right? But if you've written each one by hand, you can do it incrementally a bit at a time, and you kind of know where all the code comes from and kind of have made it work and verified at each step. So it takes a bit longer because you're not code genning, but for a small library, and even like if you're just using a subset of it, I think that's a pretty valid thing to do. And like if I'm just hacking things, that's probably what I do. But for like an open source library, I might use like code gen like we are here, which is like a minimal amount of code gen. So one of the the one we're using here is the one built into that comes with ships with GHC. Right. So what's our next type error? Client account 41 here. DB count IDs. Yep. Okay. That's because we got to go over here. That should be fine. Oh, I think I see. Yes. So create TB of account is returning list of raw TB accounts. In that case, and in this case, we're returning a pointer. Why? Return type is weird. Okay. And then this is expecting a list, not a pointer. You know what? I think maybe we'll just move this kind of code into that function. Seems like we should do that. Be a lot easier. And this needs to be... There we go. Okay, back to compiling, but obviously we still have things to implement here. So the types are lining up now. Okay, so let's go into our raw layer, implement that. Okie dokie. Hole there, one hole here. Okay, so for the top hole, we're going to malloc a packet. Something like this. Ah, yes, okay. Okay, and then pack here, yeah. Pack IDs, yes. Something like that. Okay. Change the types. Okay, we get the data size of an element times the length of accounts. Malloc the bytes by the data size. Create the count array, so that'll be like ID or TB count IDs. Then we zip together the indices over IDs. Maybe a better name would be account IDs. And book that element offset of that index into our array for TB account IDs for that account ID. And then we return the array and the size of the array. And pop that over a little bit. There we go. That's not wide word, it's word 128. What am I? Ugh. Ugh. Okay. Okay, so we got some casts here that we need to fix. We go from word 128 to void data with the key data. Maybe look up accounts. Yay. Cool, cool, cool. So we're just down to imports now. And we're all good. Okay. Let's try it out. We'll go into main. Just comment that out. And we'll look up the one we just created. All right, will it work? That is the question. Should probably set up some integration tests for these. Oh, we still have an undefined. I forgot to define something, did I? Well, there you go. It didn't work. What was it? Raw response. Oh, I haven't implemented the response. Okay. Sweet. Decode response here. That's good. So this is pattern matching of the operation. So now we have to parse the result, response. I don't know what the response for TB create accounts result is, actually. Oh, it's a great way to get banned and reported, Lippin Fumbler. If that's even your real name. Let's see. Yeah. So, I don't even know what that data is going to be. Probably it's going to be the account structs, I'd imagine, actually. Go down here. It's gonna be the size of a TB account, I think. All right, so where to implement that in the raw account here? A 0 TB account. Sorry, response. So I need to get the size of our, we need a 0 TB account. I don't like that size of needs an actual value. I get why it does. Gosh, I wish we could code gen that or something. Reverse over here, all the elements. At their offsets. And it's word 8 to TB account, I think. Get our builder going again. Check that it's all right. Yeah, that's not in scope. Okay, cool. Look up accounts response. Okay, 0 TB account. I don't think this. Hopefully, this won't get an import cycle. Okay, cool. And moment of truth. Will it work right off the bat? First try. Well, I guess it'll be second try. Yeah. No. Oh, why not? Error called. FFI.account. Oh, okay. The FFI layer. Oh, interesting. Okay, cannot match 0. Okay. Count flags. Okay, that should be... yeah. See why that might be a problem. This is not an enum. These are all bit flags. Right, it's a single uint16 value that you're, and these are all, these constants are just bit flags that you shift and you add them all together, bitwise add them all together to figure out which flags are set. And our FFI layer is trying to interpret those as enumerable values. The flags looks like. Yeah. So that's not right. We could... Oh wait, hang on. TB count flags, flags. Oh, it's supposed to be doing some marshalling here. Hang on. Okay, so it is doing the bit masks. Okay. 2 flags, okay. Okay, bit flag here. Cool. Okay, so like this is supposed to be all the code that like transforms or marshals bit flags into a set of like a Haskell set. Okay. So we are, why are we getting to this error here? Should I just delete that instance? Okay, wants the instance for that marshalling code, of course. Okay. Okay, so just add it in there. Let's get GHCID going and fix this way. It'll be much faster. Okay, no, GHCID isn't going to recompile our stuff at that level. Good to know. There we go. Sweet. TV account 8. Account ledger 8. Account code 1. Looks like the one we created. Cool. And there's the account timestamp it's created with. Sweet. And if we go up here and we do like 1, 8, like a list. Okay, account ID 1. Cool. And account ID 8. Sweet. Works. All right, let's ship it, clean it up, get it ready to go. Their main program. We'll go this way. Kill the changes to the app main. That's not what we care about here. Okay. Looks okay. Right. That we do need to clean up. Let's get rid of that instance. Let's just stage that as its own commit there. Oh, of course, of course. I forgot to set this up before starting the stream. So this all works. One of these days. I've been promising it for months that I would fix this. But I haven't. Apparently, I've been like using a VNC server and stuff. X server and stuff to forward my X sessions into Windows. But apparently that's all native now. So I can even get rid of that. I also haven't done. Anywho, where were we? Create a little community commit for that. Modify internal FFI count.hsc moved enum manual add change the I know the word I want. Replace the enum instance with a derived one on TB account flags. And see account. That's good. That's good. But I'm going to mark this as work in progress. Stage those. And we're going to call this like add lookup. Sync lookup accounts. And the reason for that is I kind of still want to do that account ID type that wraps the word 128 in the API. So even when we create accounts like ID, we could change that here. So Do like this. I like the having the accessor on it, so we'll do that. Okay, we'll get our builder going. Sweet. Okay, here. We could probably do it all the way through the module with create accounts and lookup accounts. I'll just add count.e. Let's do create accounts first. Right, gonna break some stuff. That's fine. Okay, it compiles. That should just work, maybe? Question mark? Let me... TB create or TB account. Yeah, it's a Word 128 anyway, so it's probably changing that int or casting that int, which fits into a Word 128 just fine. So I think that's probably correct. I'll just triple paranoid check. But yeah, I think that'll probably work. Right, it's going to be an account ID now instead of a raw number. I mean, that's kind of the problem with using new types, but it's also kind of good. I liked just being able to write like the raw number in there, but it's probably better. Yeah, okay. So we'll need to leave that in there as well with the change. That, changed. We count count ID. Updated the main chess. Okay, and then we can do create accounts, look up accounts. Right, so I will map those down. So the word 128's here. And then in sync. Okay, let me get rid of data.library here, and then you don't have to have it at this layer, which is nice. Very nice. And so we let's use cool. All right, let's squash that all down. Account ID. Added. Changed. Okay, and what else can we do? Yeah, I think that's pretty good. Obviously there's some fairly duplicate-ish code. I think maybe we could implement this one more round before refactoring that overall structure and making more like common kind of like code to like generate these functions. Yeah, so they're pretty similar. Okay, well, we got time. What's the next one? Probably queries, maybe? Balances. Get the account transfers, get account balances. And then query accounts. Let's do transfers or balances. Let's do balances. There's probably a struct for that. TD account balance T. Yeah. Some Word 128-bit ints here for debits pending, posted, credits pending, and credits posted. A timestamp and an array of reserved data that's probably used by the TV client itself. Okay. Pretty simple. I think we've got that in the FFI layer. Yep. Super. Storable instance for it. Love it. Okay. Next we have get account balances. It's going to take a monad IO. It's going to return a monad operation, an IO operation. Probably account IDs. Sync client T and TV response. Okay, let's get our sync state. Then we get our request packet pointer. In fact, we're going to do this. We just need to change that to and then forward pointer, sync there, back pointer. So, okay, then we rate result. Okay. I think that's good. So now we need to go over here, implement our account balances. VM pointer FFI PD package. Okay. Probably going to look very similar. Create get balances packet. That doesn't exist. So raw. It. Right, and I'm going to copy this structure again. Right, instead of account ID data, actually it's going to be account ID data. The operation though is going to be balances. That all makes sense. Okay. And then the response, we have to update the response. that. Get account balances. Okay, pattern matches, we're good. I think it's pretty much the same code there. Oh, no, except it's not. It's going to be DB count balance. Okay, and get account balances response. Okay, let's do that. That looks like it might have worked too. Let's go main. Let's get account ID 9 and account ID 1. And let's try it out. Okay, I don't like that it's got an empty array, an empty response packet though. Oh, that's not right. That's why. Okay. We need a 0 TB account balance. Just like there. E on IO. Balance. Pop those, pop there. Change that to 0. We will go end of line. Backward, white space. Backward there. That one as well. This one would just be empty. Bring that over a little bit. No response. There we go. Ooh, I need a storable instance for TBO. IO. Oop, that's probably wrong. That doesn't look right. Okay. No, that shouldn't be a storable of IO of TBO count. TB count. That's not right. Oh, yeah. Okay. There it is. Bear. Derp. Okay. There we go. Filing again. Let's test it out. Oh, we're still getting an empty response. Are we actually getting an empty response, or am I just failing to parse it? Just want to do a little check here. I'm going to import debug.trace. And we're going to... result len. Yeah, we'll print out size of result len. Try that. See what's going on. Okay, result len is 0. Okay. What do I got to do for balances? What parameters do I got to give it? Let's try the REPL, just get an idea. Ah, okay. I am possibly missing some data. Account ID 1 flags. Debits or credits. Now, is that packed into a struct? That's interesting, because I didn't see... anything like that for... account balances. Yeah, huh. Okay. Legs and IDs. Let's see what the C client library examples look like in TigerBeetle. Maybe that'll give me a hint there. I think we're on 3.2 or 3.3, somewhere around there. Clients, C, samples. Balance. It's looking up the accounts. Oh, it's just looking at right off the thing. Okay, that's not using that API. So create accounts. Transfers. Looking up accounts, we've implemented that. Okay, it doesn't have an example of that. Yeah. We could probably just. That's our header. That's the one we were already looking at. Maybe we could just look at one of the other clients, like maybe the Python client. Look up accounts. What's that? Walk through, maybe. Haskell cat decided to sit in my lap. You can go to your little bed. She's got a bed beside my desk. She likes to sit in. As for you, all right. Let's see. This one creates accounts. Look up accounts. Create some transfers. Get account balances. Okay, here we go. Ah, okay. They use an account filter for that. Okay, use the account filter struct. Okay. Okay, they set all the flags on this one, in this example at least. Okay. Okay, okay. So that's what we need to do. I don't know that we're going to have the time tonight to do all of that. But let's see what we can do. All right, so get account balances. All right, we created a request packet with the IDs essentially, but we can also give some flags as well. How do we want to do that in the API here? We could make this... no, we can use a type, just like we did for create account. This will be balances. Balances. Okay, and let's get GHCID running on this. All right, not in scope, of course. Let's create the type. We're having some consistency issues here, but I'm going to stay consistent with the local module here. Account ID. And balances. Flags. That could be a set of balance flags. What's a balance flag? What's a set, right? Let's import. A set. Now we just need the type. And need to define balance flag. Or balance debits. We'll derive enum, we'll derive bounded enum equals show. And now, get account balances, we'll take account balances. And then we have to convert those into the filter here. Or not the raw layer. Let us do it. Let's see, create accounts here, create TP account, create account packet. So ultimately we need to get a packet pointer up at this level here. This, and create account, we do it at this level, this layer here actually. I wonder if we can just pass them right down to, or if we should convert them. Let's look at the raw function. Okay, what we want here, we could just do a list of word 128s. We could do the pairs. Let's flag. You know what? Why not just let the type go down this far? That's fine. Also, except it's going to create. Might create an import cycle though. Yeah. Did not like that import cycle. Or why did? I think it's getting confused. Yeah, okay, yeah, cycle. Yeah, that's what I thought. Okay. Okay, that's not going to quite work unless we break that cycle. How do we do that? Create a module up here. these types in. And then you can get the balance flag as well, because you can import from it. And it doesn't import anybody else. But we might need word, and I think I might need to update the Cabal file. Catch. Oh, that's the problem now. Oh, I forgot to remove. Import cycle. There we go. Cool, resolved. Alright. Balance flags. Now, for grade accounts, balance packet. In order to pack our data, we actually need to pass in our balance flags. And this will be our account filter data. What the data size. We're going to cast from TV account filter the unit, the account balances. So packing here, this is going to be balance filter. We're going to return a pointer to TV account filter. Int. Maybe we can only do one. Yeah, maybe we can only do one. We can actually do a list of them. Let's do balance flag. Although it says get balances. maybe it's this stuff. Maybe it's this stuff. Okay, so we in the pack here though. Yeah. Not balance filter, balance flag. Yep. We don't have TV account filter and scope. That comes from there. Okay, account ID data. It's not going to call that. It's going to be filter data. And account filter data size. Oh, 123. Okay, let's go down here and do our packing. Let's bounce filters. Now, size of, we have to, the A here is going to be what we want. All right, we're going to want to create a query filter, or yeah, a query filter. Sorry, an account filter. So let's go down to the raw layer, account filter. Yeah, we should be able to just check that maybe here. We'll fill in all of this data. Yeah. Goes there like that, and fill in these holes. Right, so then the account ID is going to come from the balance. It's not balance flag. Account balances. I guess kind of matches, sort of. Get account ID of the A, PB, balances, account ID. Our example, we'll filter by user data. All zeros there. Filter code, no filter by code. No timestamp. Reserved. What's reserved? Empty. Zero. Limit. Yeah, 10 balances at most. I wonder if that's an option we should give, actually. That should be... Or 32. So that could be int. But balances limit and flags. Then we just have to deal with the flags. I don't have anything to do with the flags yet. Some pretend function. Marshall balance flag. What was that? That function doesn't exist, so I'm kind of running out of time. So I'm just going to put that in here, but I'm not going to define it yet. That's going to be a set of balance flag to uint 16. Oh no, okay, the marshalling is already done, so I actually don't need to do that. It's done at the FFI layer. Nice, nice. Yeah, that just needs from integral. Okay, so then we got the account filter. Or at least that one. Oh, oof. What was I doing? We just needed this one for the size of. But not really, actually. We do need it for constructing, packing these in. Grab this. A zero account filter. TV account filter. Let's balance filters, size of account filter. Yeah, okay. Get let off of that one. Go. Okay. Account filters. So when we malloc the data there, we go over the list of balance filters. And then we can pop this bad boy in here. Except we'll replace a dot with balance filter dot. And then we poke into TB account filters at index with the account filter. Return the TB account filters and the data size. Okay, cuckoo. There's something up here. Oh, gotta be indented a little bit. That should be okay. 7. Balances. Yeah, 50. Yeah. Okay, we do need one conversion there, though, from our balance flag type down to our FFI type. Okay, there's actually 3 kinds. That's okay. We should be able to do like 2 FFI flag. Not filter flag, something like that. I think there's an F map on set, if I'm not mistaken. So we just need so then we just write 2TB account filter flag. It's going to go from balance flag to PB count. Filter flags. Balance debit. 2 debits. This credit. 2 credits. Balance reversed. 2 reversed. Yeah, we should add lambda case. Yeah. And then yes, I do want to import that, yeah. Well, there is no functor. Set. What do we got? We got some kind of map. Got a specialized map, probably. Okay. Alright, that's no problem. And... oh, it's already imported as S. Okay. Right. So this needs arguments. Create that. Just needs that. Back into sync. I can import it now directly. And look up accounts as well. How's it turning into a giant commit? Probably should have broken it up a little smaller, but I'm rushing. Okay, we're compiling. Cool. Okay, and then what do we need? We need response. No, we already have response. Okay, so that's just that side, query side. Okay, let's go to our main program. So now, account balances, we go... Or database, TigerBeetle, count. Right. Let's get the, I think we created 9. We can go empty here, 10. Okay, let's test that out. Let's see. Ah, a couple of warnings, but oh, let's count balances. I probably misnamed it. It shouldn't be plural. He's an ord because of set. Right, that needs to be an account ID. Ooh. Ooh. All right. New interesting FFI issue. But we are definitely overtime tonight on the stream. So we'll have to get account balances working next week. Or maybe in between streams. I don't know. Depending on how much time we've got. But yeah. Okay. Let's get that. At least what we have so far on it going. Okay, we'll get rid of that. Yeah. Oh, right, we'll get rid of the debug. Okay, that's good. Yeah, it's probably just something, the lifetime of something. What was the couple of warnings we got there? I could probably clean those up too. That's in app main. No, I don't need to clean that necessarily. Main's broken. Because I changed imports. Cool. Yeah. Cool. Big fat one. Add. Get count balances and sync. Not working fully yet. What's in there? Okay, So thanks for watching and tuning in and hanging out with me. I'm going to push this code up. If this is your first time tuning in, welcome. Thank you for watching. It's been fun. Hope you had a good time. All the code you've seen tonight is in the GitHub. I'm Agent Ultra. I'm Agent Ultra on GitHub as well as on Twitch and various other places. And you can find the code here. You can give it a star, fork, whatever. Contribute if you want. That'd be great. File some issues. Try and create some PRs for them. Things like that would be awesome. And all that sort of stuff. You can also follow me on the Fediverse. I'm on the Mastodon. I'm on the types.pl server at Agent Ultra there. And that also has links to pretty much everything. I also back up my VODs on YouTube, so you can find the links to my YouTube there. You go to agentultra.com. That's my website. Also has links to everything too. But if you follow me there, you'll get updates of when I'm streaming or like what I'm up to, and occasional posts about other things. But I try to content warn all my stuff that isn't like mainly programming related, for the most part. What else? Yeah. If you want to know when I go online, I usually do these streams every Wednesday evening at about 10 after 8 in the Eastern Standard Time Zone. Of course, you can also give a follow here on Twitch, or if you're watching on my VODs on my YouTube channel, give us a like, give a subscribe, leave a comment, all that sort of stuff. And you'll get notified when a new video goes online or when I'm streaming, or you just write it down in your little book, whatever, how you want to do it. There you go. And yeah, come check it out. So thanks again for watching. I'm Agent Ultra. It's been a pleasure. May all your monads be free. All your types always check. And hopefully I'll see you next week. Take care out there. Happy hacking and all the best.